Here the topic is redox reactions. So let's look at what is meant by the redox reaction first. Redox reactions are the reactions in which that is the reaction which undergo oxidation and the reduction simultaneously. So the reaction which has that is both oxidation and the reduction, that reaction is termed as a redox reaction. So this is the basic definition for the redox reaction. Or we can also say that the redox reaction, it is a type of chemical reaction in which the electrons are transferred between the reactant, that is participate in reaction. So this is termed as a redox reaction. So let's look at the example. For example, let's consider A plus B. So that gives rise to, that is A plus B only. So here that is A plus and here the B minus. So here the oxidation state of this A, that would be the 0, and here the oxidation state of this B, that would be 0. And here if we look at here the oxidation state of this is reactant and these two are the products. So here if you look at the A, the oxidation state of the A, that is it loses the electron. It loses or loss of electron. And if you look at the B, that is here the gain of electron. We know that that is loss of electron, it means that it is a oxidation. And the gain of electron, it is termed as a reduction. So here that is oxidation is going on and here that is reduction is going on. So we can term this as a redox reaction because that is A is undergoing that is oxidation and B is undergoing a reduction. So here A is gaining losing one electron and B is gaining one electron. So that's why this is a redox reaction. And next look at the concept of that is oxidizing agent and the reducing agent. First let's look at oxidizing agent means. So oxidizing agent, it is defined as, so these are the electron accepting species, so which tend to undergo reduction in the redox reaction. So oxidizing agent itself undergo reduction. So next one, it is reducing agent. So reducing agent, it is defined as, these are the electron donating species. That tends to undergo oxidation. So here the oxidizing agent means that itself undergo reduction, and here the reducing agent means that itself undergo oxidation. So reducing agent, these are the electron donating species. It means that these are electron rich species. So electron rich species means the species which has for example, it contains more electron, then only it can able to donate the electron. So here the oxidizing agents, for example, that is B. So it is, that is B plus means it is deficient in electron, then only it can able to, that is accept the electron. So these are the concept of oxidizing and reducing agent. And next look at that is types of redox reaction. First one, it is decomposition reaction. And second one, it is combination reaction. And third one, it would be displacement. And the fourth one, that would be that is disproportionation reaction. So these four are the types of the redox reaction. Let's look at one by one. First one, that would be the decomposition reaction. So the decomposition reaction, it can be defined as this is a kind of reaction. It involves breakdown of a compound into the different compound, So this is termed as a decomposition reaction. Let's look at some kind of example in it. So here, if we consider that is NaH, it will break down into that is Na plus H2. If we balance this reaction, that is 2Na, and here the 2NH. So here the NaH, that is sodium hydride, it will break down into that is sodium and the hydrogen. So here this is a compound, that is sodium hydride is a compound, that is single compound. It will break down into that is two simpler compound, that is sodium as well as the hydrogen. So this is a kind of example for decomposition reaction. Let's look at another one, that is 2H2O. That gives rise to that is 2H2 plus of the O2. So this is a water. So here in this compound, it consists of the hydrogen and the oxygen. So it will break down into that is two simpler compounds, that is here this is the hydrogen and this is the oxygen. So this is the kind of example for the decomposition reaction. Let's move on further. Next one, it is second one it is combination reaction. So combination reaction, it is defined as it is just opposite to that is decomposition reaction. So in the decomposition reaction, that is AB splits into A plus B. Here it is just opposite to this. It means that is two simpler compounds combined to form the one complex compound. For example, that is A plus B, that gives rise to AB. So this is that is general reaction for the combination of that is combination reaction. So we can say the definition, that is involves the combination of two compounds to form a single compound. So this is a definition for the combination reaction. So if we consider the example, that is H2 plus Cl2, so that gives rise to that is 2HCl. So here this is the hydrogen, this is the chlorine, that combines to form the hydrochloric acid. So next one, let's look at another kind of example, that is 4Fe plus of the 3O2. So that gives rise to that is 2Fe2O3. So this is the iron and this is the oxygen that combines to form that is ferric oxide. So this is an example for the combination reaction. In general, we can say that is two lighter compounds or two single compounds that can merge together to form the one single compound. So these two are the single compounds. Sorry, these two are that is individual compound that get merged together to form the one single compound. So this is an example and the definition for the combination reaction. Let's move on further. Next one, it is third one, that is displacement reaction. So here it is a kind of reaction in which an atom or an ion in a compound is replaced. So there is no particularly atom or ion. So either atom or the ion that is replaced in a reaction. We represent that in a general form, that would be like this, that is X plus YZ, that gives rise to that is XZ plus of Y. So here that is Z that will attach to the X. It means that here that is Y replaced by the X. So this is Y and this is here the X. So here the Y replaced by the X. So this is a general reaction for the displacement reaction. So here displacement reaction, there are two types. First one, it is metal displacement reaction. Metal displacement reaction. And the next one, that would be the non-metal displacement reaction. Non-metal displacement reaction. So let's look at one by one. First one, it is that is metal displacement. Metal displacement reaction. Let's look at that. So here it is a type of reaction in which metal present in a compound that is displaced by the another metal. So this is the definition for the displacement reaction. So if we consider the example, that is, let's consider that is copper sulfate, CuSO4. This is example that reacts with the zinc. So it will produce us that is copper plus ZnSO4. So here the metal that would be that is Cu and the Zn. So Cu, it is a copper, and Zn, it is a zinc. So here that is the copper get replaced by the or displaced by the zinc. That is copper displaced by zinc. So here that is copper sulfate get converts into the zinc sulfate. So this is the zinc sulfate. So copper sulfate get converts into the zinc. So here the copper it is displaced by the zinc. So this is an example for the metal displacement reaction. Here copper and the zinc both are the metals. Next one, that is non-metal displacement reaction. So let's look at what is meant by the non-metal displacement reaction. So it is a kind of reaction in which we can find that is hydrogen displacement and sometimes we can also find that the oxygen displacement. So here in the non-metal displacement, there is no any kind of the metal displacement takes place. So but particularly hydrogen and oxygen get displaced. So this particular reaction, that is termed as a non-metal displacement reaction. For example, if we consider that is 2Na plus that get reacts with the 2 moles of water, that is H2O. So it will produce us that is 2Na OH plus of the H2. So here only that is here the sodium present and here the water present. So that will combine to form that is sodium hydroxide and the that is hydrogen. So here only the displacement of the hydrogen and oxygen takes place. So that's why this is a non-metal displacement reaction. So here there is no any kind of the metal displacement, only the hydrogen and the oxygen get displaced. So that's why this particular reaction it is termed as a non-metal displacement reaction. Next one, it is disproportionation reaction. So if you look at the definition of the disproportionation reaction, it means that in which a single reactant it is oxidized and reduced. So this reaction it is termed as a disproportionation reaction. For example, if you consider that is example PF plus of the 3 NaOH plus of the 3 H2O. So here that gives that is 3 NaH2 PO2 plus of PH3. Here the oxidation state of the phosphorus, that is plus 4, and here the phosphorus oxidation state, here it is 0, and here the phosphorus oxidation state that would be that is plus 3, and here that is this undergo that is oxidation, and here this phosphorus this undergo here the reduction. So here the phosphorus, that is single reactant that undergo both oxidation and the reduction. So here the phosphorus that undergo both oxidation and the reduction. So this particular reaction it is termed as a disproportionation reaction. Here let's look at some example for the redox reactions. First, let's look at the reaction between hydrogen and the fluorine. So here, let's look at the reaction between the hydrogen and the fluorine. So here the H2 plus of the F2. So that will give rise to 2HF. That is, if we look at that is oxidation reaction. That would be, so here the oxidation that will undergo, that is H2 that gives rise to 2H plus of the 2 electron. And if you look at that is reduction reaction. So here that is fluorine undergoing the reduction. So here F2 that will give rise, that is with the addition of the 2 electron, it will give rise to, that is 2F minus. So if we add the both, that is reaction, here the 2 electron gets cancelled. So finally we get that is H2 plus F2. So that gives rise to 2HF minus, that is 2HF. So this will that is final redox reaction. So here the hydrogen undergoing the oxidation reaction, it means it is losing the electron. Here losing of electron, that means it will losing the 1 electron, that is 2 electron. And here that is fluorine, it is undergoing reduction reaction, it means here it is gaining electron. So here this is that is reaction between the hydrogen and the fluorine. Let's look at the next example. Next, look at the reaction between that is zinc and the copper. So here that is, as I already said, zinc and the copper, these are the metals. So this will, that is definitely undergo the metal displacement reaction. Let's look at how. That is Zn plus Cu SO4, that gives rise to Zn SO4 plus of the CuS. So if we write the state of this metals and the compounds, this is aqueous, and here also this is aqueous. So here that is oxidation reaction that will undergo, that is zinc Zn, that gives rise to Zn2 plus of the 2 electron. So here that is zinc losing 2 electrons, so that's why it is undergoing the reduction, it means losing electron. And if you look at the next one, that is here the reduction undergoing by the copper, that is reduction undergoing by the copper, that is Cu. It will, that is Cu2 plus, it gains the 2 electron and it will becomes a neutral, that is Cu. So here it is gaining the 2 electron, and it becomes a neutral. So that's why this is the reduction reaction. If you write the overall reaction of the zinc and the copper, that would be like this. That is zinc that get reacts with the Cu2 plus, it will produces the Zn2 plus of the Cu. So here zinc undergoing oxidation, and here that is copper, it is undergoing, that is reduction. So here the zinc, it acts as a reducing agent, and the product obtained here, it is, this is oxidized product. And here the copper, this acts as a, that is oxidizing agent, and here this copper, it is a, that is reduced product. And next look at another example, that is the reaction between the iron and the hydrogen. So here that is iron, that would be, if we write the reaction between the hydrogen and the iron, that would be like this, 2Fe2 plus, that get reacts with the hydrogen peroxide, that is H2O2, that get reacts with again the 2 hydrogen, that is H plus, so that will produces the 2Fe3 plus of the 2H2O. So if you look at the oxidation and the reduction reaction, let's look at first oxidation reaction. So here that is oxidation takes place by that is iron, Fe2 plus. So it will convert into the Fe3 plus by losing of That is here the Fe2 plus get convert into the Fe3 plus by losing the that is electron. One electron get lost, and that's why 2 plus get converts into the 3 plus. So after losing it, that is after losing of one electron, here the losing of one electron takes place. So that's why this undergo oxidation reaction. So if you look at the reduction reaction, so that would be like this. That is here the hydrogen peroxide H2O2 that gains 2 electron, and that converts into the it is 2OH minus. So here that is hydrogen peroxide that gains the 2 electron and converts into the hydroxide. Let's look at some kind of that is important oxidizing agents. Oxidizing agents. So here the molecules made up of the that is electronegative elements. Electronegative elements. Why particularly electronegative elements? That is because these electronegative elements have the capacity to gain electrons. That's why we should only consider the electronegative elements. So that is some kind of electronegative elements such as that is O2 oxygen and O3 that is ozone, and the X2 this is halogen. So these are the electronegative elements. So these can gain the electrons. So that's why this can act as a that is oxidizing agents. And if you look at the compounds containing a element that has the higher oxidizing state, for example, that is KMnO4 and K2, Cr2, O7 and HNO3. So these are acts as a that is oxidizing agent. And if you look at the reducing agents, so reducing agents which has the capacity to donate electrons. So these must that is reducing agents are the species which has the capacity to donate the electrons. Let's look at some kind of example. That is all metals acts as a that is reducing agent. For example, the sodium, zinc, iron, aluminium, etc. So these are the all metals are example for the reducing agent. And if you look at some non-metals also, that is carbon, hydrogen, sulfur, phosphorus. So these are the example for the reducing agents. And hydro acids. So that is HCl, HBr, that is hydrochloric acid, hydrogen bromide, and HI, hydrogen iodide, etc. So these are the some important reducing agents. Next, look at the balancing of the reaction. Balancing of reaction by using a redox reaction. So for example, let's consider that is Cr2O7 plus of the SO3 that gives rise to that is Cr3 plus of the SO4 2 minus. So here that is CrO7 2 minus and here SO3 2 minus. So here in the presence of the H plus. So let's balance the reaction. So let's consider first that is reaction, half cell reaction or half reaction. Reduction reaction. So here that is chromium, here it is convert into the 3 plus. So here initially it is in a +6 oxidation state, and here it converts into the that is +3 oxidation state. It means it gains the 3 electrons. So that's why it is undergoing a reduction. And here that is the oxidation state of the sulfur, here it is the +4, and here it converts into the that is +6. It means that here losing of the 2 electron minus 2 electrons. So that's why it is undergoing oxidation. So if we write the reduction reaction, that is Cr2O7 2 minus, that converts into the Cr +3. So if we write the balanced reaction, that would be Cr2O7 2 minus. So if we balance this, so it becomes 2Cr +3, and next Cr2O7 2 minus, that gives rise to 2Cr +3 plus of the 7H2O. So at last we get here that is Cr2O7 2 minus plus of the 14 H plus of the 6 electrons. So that gives rise to 2Cr plus 3 plus of the 7H2O. So this is that is reduction reaction. If you look at the oxidation reaction, let's look at that. Oxidation reaction. Oxidation reaction. So here the oxidation takes place by the sulfur, that is SO4, 2 minus, so that get converts into that is SO3, 2 minus, that get converts into that is SO4, 2 minus. So here the SO3 2 minus with the addition of the water molecule H2O, that get converts into the SO4 2 minus, and next that is SO3 2 minus plus of the H2O, so that gives rise to that is SO4 2 minus plus of the 2H plus of the that is 2 electrons. So let's multiply this reaction by the 3. So at last we got here that is 3 SO3 2 minus plus of the 3H2O, that gives rise to 3 SO4 2 minus plus of the 6 H plus of the that is 6 electron. So if we add the both oxidation reaction and the reduction reaction, we get the final redox reaction, that would be like this. We obtain the that is reduction reaction, that would be Cr2O7 2 minus plus of the 14 H plus of the 6 electron. So that gives rise to 2Cr plus 3 plus of the 7 H2O, and next that is 3 SO3 2 minus plus of the 3 H2O plus of the 3 SO4 2 minus, that gives rise to the 6 H plus of the 6 electron. So after cancelling, here the 6 electron gets cancelled, and here the 3 water molecule is present, and here the 7 water molecule is present. So 3 water molecule get cancelled, and remaining that would be 4 H2O. And next here the 6 hydrogen is present, and here the 14 hydrogen is present. So the remaining that would be 8 hydrogen. 8 hydrogen. So if we add both the reaction, we get the final reaction, that would be Cr2O7 2 minus plus of the 3 SO3 2 minus, that gives rise to 2 Cr3 plus of 3 SO4 2 minus plus of the 4 H2O plus of 8 H plus. So this would be the final balanced redox reaction. So let's look at the example of the redox. Let's look at the applications of redox reaction. So it is generally used in electrochemistry. And the redox reaction is helpful or used in that is photosynthesis. So let's look at the example. So here that is, we know that the green plants convert the water and the carbon dioxide into that is water plus the carbon dioxide into the carbohydrates, that is glucose hydrates. So let's look at that is reactants. That would be 6 carbon dioxide and the 12 H2O. So the products, that would be that is C6H12O6 plus of the 6 H2O plus of 6 O2. And here if we write the final reaction, that would be that is 6 CO2 plus of the 12 H2O. So in the presence of the light, it is H. So it will produce us the C6H12O6 plus of the that is 6O2 plus of the 6H2O. Here the carbon dioxide, that get reduced to that is CO2 reduced to that is carbohydrates, and here the water, that get oxidized to oxygen. That is oxidized. So here the reduction and the oxidation reaction takes place simultaneously. So this is the redox reaction. So here the final product, that would be the carbohydrates plus of the oxygen. So here this is the reduce or reduction, and here the water get converts into the oxygen, that would be that is oxidation. So this is the reduction, and here this is the oxidation. That means reduction means it gains the electron. Oxidation means it loses the electron. So this is the concept of redox reaction.